everyone. Welcome to the Day 8 notes. We have been talking about normal curves, and today we're just going to continue on with our discussion about normal curves. So one way to compare things is, of course, by finding percentages, but another way to do it is to tell how many standard deviations a person is above or below the mean. Remember, the mean is the average. That's called a z-score. This is the formula for the z-score that we have been using. Sometimes in place of the mean, we put the mu, which is the Greek symbol for mean, or most of the time we've been using x bar that we get off of our calculator. Down here at the bottom for standard deviation, we've been using sigma x, okay? So let's take a look at the information that you have right here, and let's try and figure out what Jenny's z-score is. In order to figure that out, the first thing we're going to need to do is we're going to need to find the average for the data, x bar, and we're going to need to find the standard deviation. So let's start by finding those first. Let's type in all of our data into our calculator. And you can slow down or speed up the video at any point. It's going to take me a couple of moments here to get all this stuff all the data entered into this correctly. Hopefully everybody is having a pleasant experience at home. Oops, looks like I lost the spot on my data. 83, 89, 78, 84, 80, 82, 75, 77, 67, 72, and 73. Okay, so I'm going to go to Stat, Calculate, pick one variable, Stats. Now I've got all my data in list 1, and I'm just going to clear out that frequency list because I don't have one. So for this data, I find out that my x bar is 80 and my standard deviation is 5.95, or if you want, you can call it 5.9, or you call it 6. Both of those would be good. So first thing let's do, let's use our calculator to calculate the z-score for Jenny. All right, so her z-score is going to be 86 minus 80 over 5.95. Okay, so using your calculator, go back out to your home screen. 86 minus 80 divided by 5.95. Okay, so I get a z-score of 1.00, and when I go to my calculator and I'm going to put this into my calculator to calculate this, I'm looking for the probability that the random variable x is, let's see here, percentile is less than 86, or I can say it as the probability that z is less than 1.00. Okay, so let's try just with the 86. So we would go to our distro menu, pick normal CDF, type in 80, well, we want a really small number, so negative, make it huge, to 86. Then you're going to put in your mean, and your mean in this case is 80, and your standard deviation is 5.95. You're going to paste that. So we would come out with 0.84, or about 84%. What if we want to do it with z-scores? Again, we can do the same thing. So we'll go to the distro menu, pick normal CDF, really low number. Upper value on this is going to be 1. Your mean when you do a z-score is 0, and your standard deviation is 1. Let's paste that all in. Notice you get almost the exact same answer. Okay? So let's find out what the z-score would be for a person who made a 72 on the test. Okay, so let's see here. I'm going to go back over here. I'm going to do 72 minus 80 divided by 5.95, and I end up with negative 1.34. Now, how can I use this to compare? If you think about a z-score as being on a normal curve, our first person, Jenny, she made a score that's over here. That's where Jenny is. I'll put a little j. Our other person has a negative 1.3, so their score is over here. So Jenny clearly did better. Let's take a look at an example that many of you will experience, which is SAT scores. So if a person has a 500 with a standard deviation of 100 on the SAT, and an 18 with a standard deviation of 6, say that you made a 680 on your test and a 27 on the ACT. Which one did you do better on? So let's calculate the z-score first for SAT. So when you do the SAT, you're going to take your SAT score. You're going to divide that by 100. So you'll do 680 minus the mean divided by 100. So that's about a 1.8. Okay, let's do the same thing for the ACT. Okay, so you're going to take 27 minus 18 divided by 6. So 27 minus 18 divided by 6. That gives you a score of 1.5. Now, the closer you get to a positive 3, the better you did. And since that's a 1.8, I would say that you perform better on the SAT. So hopefully that explains things pretty well on that. All right, now we've got another person, Eleanor. She got, her z-score was a 1.6. I'd like to know what her actual score was. So I'm going to take my equation and I'm going to put in my 1.6 over here. This is just a little bit of an algebra problem. I have a mean of 500 and a standard deviation of 100. Okay, so algebra-wise, first thing you do, take your 1.6, multiply it times 100, and you get 160. And then you're going to take that 500, move it to the other side. So you got 660 was her actual score that she made on the SAT. Now, a couple more exams that you might take when you eventually go to graduate school. One is the GRE, and the other one is the Miller Analogy Test, the MAT. So I've got some information there. You decide to take both tests. Let's see which one you did better on. So again, we're just going to do our z-score calculation. Should be nice and easy. So here's the z-score for the GRE. So you have a 1875 minus the mean of 1500 divided by the standard deviation of 300. Then you've also got the MAT score. And for that one, you got a 57 minus the 50 divided by 5. So you just need to put all this into your calculator. 1875 minus 1500 divided by 300. That gives you a 1.25. Definitely better than average. 57 minus 50 divided by 5 gives you a 1.4. So you did better on the Miller Analogy Test because you are more standard deviations above the mean. Okay, so let's take a look at Judy. Judy's a 25-year-old who has a bone density measurement that is 948 grams per centimeter squared, and that's the standard deviation. So let's take a look at her hip measurement. That's the average. Oh, I'm so sorry. The mean is this, and that's her score. So as you can see, she's a little below average, but let's see how bad it is. Okay, so here is our formula. And then we're going to fill in what we know. So we know that her results were 948. We know the mean is 956, and looks like we don't know what the standard deviation is for this population. That's what I'm looking for. I don't see it. So that means we're going to need to find it, but we do know her z-score. Okay, so again, doing a little algebra going backwards, sigma goes to the other side. So I've got a 948 minus 956. And then I'm going to divide by the 1.4, well, negative 1.4. So I get 5.2 approximately is her standard deviation. So let's talk about what her score is. So her score is a negative 1.45, which means she is below average if you consider that average would be a 0. So if I look at the data here, so there would be your average of 956. And she is over here somewhere. That's where Judy's score is. So she is definitely below the average for her age population. So explain to her in simple language what it means. I would tell her that her score is below average, but not an outlier, and that her bone density is not normal, because normal is going to be some number right around 956. So her bone average is below average. Now, should you give Judy medical advice? Absolutely not. Please don't give her any kind of medical advice. Okay, so let's do some of these percentile problems. So first thing I'd like to do is I'd like to know, if I'm thinking about a normal curve, I'd like to know about the bottom 10%. Now, in order to do bottom 10%, you're going to do inverse norm. And when you do inverse norm, the area to the left, that direction of that you're trying to find, is going to be 10%. So you do 0.01, and then you're going to put in your mean, and you're going to put in your standard deviation. Now, when you do all of that with your calculator, you should end up with about 12.03 ounces. Now, the one that's a little harder is the top 10%, because you really got to think about what you're doing here. So top 10% means the 10%'s over here. Now, what's tricky about that is if you do inverse normal of 10%, you're going to come right back out with 12.03 ounces of potato chips. Instead, you want to think about the bottom 90%. So you're going to do inverse norm with a 0.9, a 12.8, and your 0.6, and that's going to tell you that the z-score that goes with this information is, well, my mean that goes with this information is going to be 13.57 ounces. So that's probably our hardest one out of the bunch, because when you put things into the calculator, the number that goes here has to be area to the left. So that's always a little bit of a challenge with inverse normal. So when you're thinking about inverse norm, the first number is area to the left. Then you're going to put in your mean, and then you're going to finally put in your standard deviation. So that's all there is for day 8. Hopefully your practice problems for day 7 and day 8 are going really well. If not, of course, send me an email and I will record some extra information just for you.